let's talk about the central question of this chapter. The idea is we have a lot of different populations, and we want to test whether all of their population means are the same. Okay? So, we have many populations. That's usually denoted by a capital I in this context. So I of them. And so the question is, do they all have the same population mean? Good. So in other words, think of this in terms of the hypothesis that we're testing. So we can say if we have I populations, so let's say population x1 has distribution mean 1 and some standard deviation sigma. And x sub I has normal distribution with different mean and so on. So the hypothesis we're testing is whether or not the mean of our first population is equal to the mean of the second population, and that's equal to the mean of the third, and so on. And the alternative hypothesis is that some pair of these means is not equal. Some pair of these mu's are not equal. Okay? So this is basically a generalization of what we did in chapter 19. Right? In chapter 19, we just had two different populations, and we talked about using the two sample p statistic to ask whether or not just two populations are equal. But now we're doing it for any number of different populations. Okay? So, for example, we could look at different types of cars, and we can ask, do they have different mileages on average? Right? So for instance, you could look at mid-sized cars, SUVs, and pickup trucks, and ask, on average, do all of these cars have the same gas mileage, or is there some difference between some pair of them? Okay. And so the null hypothesis is that all three of these means are exactly the same. Okay. So how do we answer a question? Well, we always start by collecting data. So here, the EPA actually has data on this stuff. So we look at their data, we see that they've sampled like 31 mid-sized cars, 31 SUVs, and 14 pickup trucks. Okay? And it doesn't matter if they have the same number of samples in each population or not. It doesn't matter that they have only 14 pickup trucks. Okay? So we can look at this data that we have. We can compute the sample means for each of these three different types of cars. And we get the following numbers. We get a mean of 28-ish for midsize, mean 3 for SUVs, and 1 for pickups. But as with everything in statistics, it's not that surprising to get different numbers. Of course, we get different sample averages, no matter what's going on. The question is, how different are these sample averages? Or is there a statistically significant difference? Okay? can we associate some sort of p-value to this data, basically? And so that's what this chapter is about, basically. How do we associate a p-value to this sort of data? Okay. Any questions so far? So, after learning chapter 19, you might think, all right, we could just individually look at each pair of cars, right? Testing whether all three are the same. This is the same thing as testing whether each pair of cars is the same. So it's the same thing as saying that the first mean is equal to the second mean, the second mean is equal to the third mean, and the first mean is equal to the third mean. Similarly, we can restate our alternative hypothesis. So the alternative hypothesis is that some pair of these means is not equal. So that's saying, in this case, the mean for mid-sized cars is not equal to the mean for SUVs, or the mean of SUVs is not equal to the mean for pickups, or the mean for mid-sized cars is not equal to the mean for pickups. So we can reduce this question basically to considering pairs of populations at a time. But it turns out to be a problem with this. And this is what's called the problem of multiple comparisons. We mentioned that last time a little bit. So the point is there's a problem with just comparing two populations at a time. And basically, the point is that this makes it really hard to compute what your p-value actually is. Okay, so let's talk a little bit about sort of how this happens. And let's say we wanted to test so let's say we wanted to test the hypothesis that each of these things are equal. So our null hypothesis is that these three means are equal. And let's say we want to use a particular alpha value. So let's say we're testing this at an alpha of 0.05. Okay. So the point here is that we can't just test each pair of means at the same alpha level. Okay? So why not? Well, Well, let's think about what alpha actually means.